Good day children, welcome to another video session in maths. Today we start chapter 2 polynomials. Now before we go to polynomials, you have learned about algebraic expressions. What are algebraic expressions? I give you few examples. Say 2x plus 5, this is an algebraic expression. If I say again an algebraic expression, again an algebraic expression. Okay, now so what are polynomials? I say this one is a polynomial, this is a polynomial, but this is not a polynomial. Why? Because see this power of the variable. What you find here is x is a variable, power of the variable is -1. So this is not a polynomial. So for a polynomial, you have to see that the power of the variable is a whole number. Okay, so you see here x means x to the power 1. This is a polynomial. Here what's the variable? X. What's the power of x? 2. So this is a polynomial. Let's take a few more examples. Suppose I say is this a polynomial? Yes? No. This is not a polynomial. Why not a polynomial? Because root x is actually x to the power 1 by 2 and 1 by 2 is not a whole number. Therefore, this is not a polynomial. So, understood children? So, when do we say a given algebraic expression is a polynomial? When the power of the variable is a whole number. And you know what do we call here this 2? 2 is constant, x is variable. What does variable mean? Variable, that is, here we have x, x can have any value, whereas a constant has a fixed value. For example, this 5 is a constant, means the value of 5 will be 5 always, but x is a variable, that means x can have different values. Okay, so this is constant and variable, and we have seen the power has to be a whole number for an algebraic expression to be a polynomial. Now again see here, suppose we take this one. For this we have two terms. Which are the two terms? This is the first term, this is the second term. So in a polynomial, the terms are separated by either plus or minus sign. Let's take another example. Suppose I have 4x cube minus 3x square plus 5x minus 2. Now how many terms are there in this polynomial? This is the first term, that is a minus. So this is the second term, this is the third term, and this is the fourth term. So in this polynomial there are 4 terms. So that is the terms of a polynomial, they are separated either by plus or minus signs. Next, suppose I say what is the coefficient of x square? Coefficient means this value with x square. So coefficient of x square in this polynomial is -3. What is the coefficient of x? 5. So clear children, what are coefficients and terms? Okay. Now for a polynomial with one term, we call it monomial. Polynomial with two terms is called binomial. With three terms, we call it trinomial. And more than three terms, that is 4, 5, etc., we in general call it a polynomial. Okay, so depending on the number of terms, a polynomial can be a monomial when there is only one term, can be binomial having two terms. If there are three terms, we call it trinomial, and more than three terms in general is called a polynomial. Okay, next, suppose we take another polynomial. Now see here, in this polynomial, the power of the variable is 1. We call it degree. Degree is the highest power of the variable. In this polynomial, the power of the variable is, there is only one variable x and its power is 1. So, degree of this polynomial is 1. In this polynomial, see here, the power of x is 2. Here the power of x is 1. So, which is the highest power? Highest power is 2, and therefore, degree of this polynomial is 2. So, okay children. So, degree is the highest power of the polynomial. Now, a polynomial with degree 1 is called a linear polynomial. If the degree is 2, we call it quadratic polynomial. Similarly, if the degree is 3, we call it a cubic polynomial. Okay, understood children? So, these are some basic concepts which you will be, which you need to know to solve your exercises. Okay, so children, now let's move to exercise 2.1. Now, see exercise 2.1, the first question. What is said here? Which of the following expressions are polynomials in one variable and which are not? Now, we have to say whether these are polynomials or not. See the third one. Is this a polynomial? Is this a polynomial? Yes or no? This means root t means t to the power 1 by 2, t root 2. So, what you see here, the power of the variable t is 1 by 2, which is not a whole number. Therefore, this is not a polynomial. Let's see another one. Suppose this one. Is it a polynomial? Let's check it. Y plus 2 by y. We take this y here to the numerator. What will happen? Power becomes minus 1. So, now what do you see? Is the power a whole number? No. Therefore, again this expression is also not a polynomial. Understood children? So, when is an algebraic expression a polynomial or not a polynomial? Next, see question number 2. Write the coefficients. Write the coefficients. Suppose question number 2. Let us take the second one. 2 minus x square plus x cube. You have to write the coefficient of x square. So, find out the term x square, this one. What is the coefficient? The constant with this x square. What is it? 1. So, here the coefficient of x square will be not only 1 with the sign minus 1. Okay. Question number 4 is to write the degree of the following polynomials. Okay, come on, let's take another one. Question number 4, let's see the second one, 4 minus y square. What is the degree? Degree is the highest power of the variable. Now, what is the variable here? Y. And what is the power of y? 2. Therefore, degree of this polynomial is 2. So, understood, children? So, now we have learned what is a polynomial, different types of polynomial, that is monomial, binomial, trinomial, etc. Degree of a polynomial, depending on the degree we can say whether it is a linear or quadratic or cubic polynomial, and coefficients of any terms, x square. What is the coefficient of x cube here? Coefficient of x cube will be 1, and so on. So, I hope you understood up to this, children. Okay, come on. Next, move to a new topic, zeros of a polynomial. Okay, children, the next topic is zeros of a polynomial. Now, what do you mean by zeros of a polynomial? For example, suppose I take a polynomial. Polynomials are denoted this way, px. Suppose I take any polynomial. X plus 2 is a polynomial? Yes. Power of x is 1. Now, suppose in place of x, I put minus 2. So, p minus 2. So, here in place of x, I put minus 2. Minus 2 plus 2 equal to 0. So, I say minus 2 is a 0 of the polynomial x plus 2. Okay. So, what do we mean by zeros of a polynomial? That value of x for which the value of the polynomial becomes 0. 0 of a polynomial is that value of the variable, here it is x. So, that value of the variable for which the value of the polynomial becomes 0. Here, if I put minus 2 plus 2 is 0, therefore, minus 2 is a 0 of the polynomial. Now, for a linear polynomial, there will be maximum 1 0. For a quadratic polynomial, maximum 2 zeros, and so on. So, understood what is a 0? That value of the variable for which the value of the polynomial becomes 0. Now, based on this, you have your next exercise, that is exercise 2.2. Now, let us see a few sums from this exercise. Now, see there, the first question, find the value of the polynomial 5x minus 4x square plus 3 at, let us take the second one, x equal to minus 1. You have to find the value of this polynomial at x equal to minus 1. So, how do? We say let px is this one, the given polynomial. You have to find the value at x equal to minus 1. So, what do? In place of x, we substitute minus 1. So, 5 minus 1 minus 4 minus 1 square 3 minus 5 minus 1 square is 1. So, 1 into minus 4 plus 3 minus 5 minus 4 is minus 9 plus 3, that is equal to minus 6. So, the value of this polynomial at x equal to minus 1 is minus 6. Okay, let's see another one. Question number 2, find P0, P1, P2 for each of the following polynomials. Okay, let's see. Let's take another example from question number 2. Question number 2. Again, come on, let's take the last one. Px equal to x minus 1 into x plus 1. You have to find P0, P1 and P2. Come on, P0. What we have to do is just put 0 in place of x. 0 minus 1, 0 plus 1. So, what you have, 0 minus 1 is minus 1 into 0 plus 1 is 1. It's minus 1. We find P1. 1 minus 1, 1 plus 1. 1 minus 1 is 0 into 2, that is 0. And P2. Put 2 here in place of x. 2 minus 1, 2 plus 1. 2 minus 1 is 1 into 2 plus 1 is 3. You get 3. So, this is how we find the values of the variable for a given polynomial. Hope you understood, children. Okay. Next, let's see the next question. Question number 3, verify whether the following are zeros of the polynomial indicated against them. Okay, see, polynomial is given, some value is given, you have to substitute in place of the variable. If you get 0, it is a 0. If you do not get 0, then it is not a 0. Come to question number 4, find the 0 of the polynomial. Okay, come on, let's take question number 4, the first one. Px equal to x plus 5. You have to find the 0 of this polynomial. Now, to find the 0 of a polynomial is equating the polynomial to 0. Okay, if you equate the given polynomial to 0, you get the 0 of the polynomial. That is, Px is x plus 5. How to find the 0? For 0, x plus 5 equal to 0, this gives x equal to minus 5. So, minus 5 is a 0 of the polynomial, isn't it? You can easily check it, substitute minus 5. So, minus 5 plus 5 is 0. Okay, let's see another one. Suppose take the third one, Px equal to 2x plus 5. How to find it 0? For 0, 2x plus 5 equal to 0, or 2x will be equal to minus 5. So, x will be equal to minus 5 by 2. So, minus 5 by 2 is a 0 of this polynomial. Okay. You can always check it. Let's substitute minus 5 by 2 here. 2 into minus 5 by 2 plus 5. 2 cancel, minus 5 plus 5 is 0. So, what did we get? Minus 5 by 2 is a 0 of the given polynomial. So, understood, children? So, this is how we find the 0 of a polynomial. So, children, let it be up to this much for today. We will continue it in our next class. Thank you.